Okay. Good afternoon, everyone. So for today, select some problem that is, I think, interesting to check. Okay, and I hope I can cover most of the topics for today. Okay, but let's see if we can solve like how many questions and how many problems for today. In your TA, I think several questions already discussed, right? And also, I think you got the PDF file or not? The yeah the TA, right? Yeah, okay. So that is uh, usually the typical exam that I'm usually arrange. Um, let's see if I have prepared for you. Okay. I already prepared for you. Okay. Okay. First is this is from chapter 2. This is to see how the functions can be differentiable or not. Right? Okay. So first, just check the questions and see how we can solve this question. So define that you have a function, okay, f of x, and you have three different equations, okay, based on the interval of x. Okay, so when you have x less or 0, it will be having an exponent, and if you have x equals 0, it should be an equal to a constant m, and when x is positive, it is having an exponent, and the question is asking the constant when the function is differentiable everywhere. Differentiable everywhere. Yeah, that's the whole question. And to solve this, I think it's not only using just from chapter 2, but I think you can also include most of the knowledge that you have between chapter 1, 2, 3, 4. But now, when you have learned the topics about derivatives, okay, we are not looking at the questions like maybe, oh, this is the question from chapter 2, this is question from chapter 3. Maybe it's a combination between those chapters. So uh, you can solve it in any way you think it's possible. Okay? But the clue here is the function should be differentiable everywhere. So you need to have some definition here, right? So what is the definition for a function to be differentiable? That's the key. It is key. And you can think using limit. Okay, I've give you several minutes, okay, maybe a few minutes to think and try. Okay, can you solve this kind of question? Okay, let me zoom in this equation if you think this is too small. Okay, this. Okay, so the equation is a e with power of x plus bx, okay? And then m. The third one is e negative. This happened. It's too sensitive. Okay. Okay. E negative 1 over x squared plus this is cube root 3 x plus 5. And if the, for example, if this is a question in a in exam, if what you need to do is first, it's not about finding A, B, and M. Not only that, we need to provide with some uh, some proof. Okay? For example, the question is asking that we need to find the constant when the functions is differentiable everywhere. So we need to provide that what happens when the function is differentiable. Okay? And then you need to provide that step. After you provide that step, then you can go to check the constant. Check the constant. Whenever you feel that okay, maybe using this proof, using this formula, maybe using this theorem or definition, you need to state all the possible way that you think that's correct. Okay, fine. Mhm. Yeah, 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 yeah. Good one. Using limit. Okay. Okay. Anyone fine? So first step, using limit. Okay. Differentiable means it should be continuous. Okay. Continue means limit from the left and right should be the same. That's continuity. The second one, of course, you need to use limit definition. Okay. Limit definition to see that it should be differentiable everywhere. So you need to use some formula for definition of it. Okay, so after you find the continuity, you need to find the limit definition of derivative. Okay, let me write some important notes for you. Okay, so first is continuity. Okay, so first is about continuity. So first continuity means that when you have a limit, when you take from the right, then this should be the same as when you have from the left. And differential, that means right, derivative base the derivative. It is also to check this because it said it's differentiable everywhere. So you need to make sure that this is correct. This definition is correct. Okay, so basically, within these two very basic formula in the limit, okay, checking continuity, checking differentiable everywhere, meaning you can derive using this limit definition from the left or right. Okay, should be equal, or should be you can find those number. Okay, and of course from these two uh, principles, when you apply to our function, we can find the constant. I think the continuity, I think some of you already find that is, we can use this 0 as our, how to say, as our parameter. Okay, so let's say we can approach the x to 0. Let's say from the right. From the right means we have this one, right? So let's say this is, let me write the equation here. Okay. Okay, this means that, let me write slowly one by one so you get the idea. This is the limit. Okay, this will be 0, right? Okay, okay. If you maybe didn't really know, if we put 0 to the x, it will be this, right? Remember when you have, we're using black. I think it's better to just draw this. Okay. This is e to the x, right? Okay. And this will be e to the negative x. Okay, anyway, if we have negative infinity here, approach here is going to 0, right? Or if we can look this negative x approaching infinity is going here, right? Yeah, both are going to 0. So this part will be 0, okay? Okay, okay, that is the first. And the second one here is just 5 with cube root, okay? Okay, that is the limit from the right, right? Okay, now if we maybe use a different color, check the limit from the left. This is precisely the constant, right? The a, let me write a e with power of x plus bx, okay? Then we compute this, we compute, and this will be just a, okay? Just a. And because we know that it's differentiable everywhere and we need to have a continuous, right? So our a should be our m, right? Okay, and should be equal to this. Okay, so because of continuity, then we can have this, right? Okay. Okay. Now we haven't finished yet. we still have B. Okay, we need to find B. Okay, let me put down here. Okay, let me maybe write where, maybe here. Let me use green color. Now, for a derivative, we can check the derivative with the limit approach, 0 from the right of our limit definition. Okay, let's check this first. Okay, for this from the right. The right is this equations, right? So we may have E, a little bit calculations, but I think should be okay. Okay. And then F0 will be the constant square root of 3, 5, and then X, right? Okay, of course, this one, we already compute that it's the same as our constant, right? And this will be 0, 0. Then we can use Lopita rule. Okay, so it's not necessary about the only chapter 2, but it's also combined with chapter 4. So because first we check, okay, first we check 0 over 0. Okay, and in your paper in exam, if you want to use Lopita rule, make sure you write that this is 0 over 0. Okay, to prove that okay, we can use Lopita rule. Okay. Then we can use the L'Hopital rule. Okay. And then we different color. And then take slowly. Okay, this become 1. E, it's just E, still E. Need to multiply with what? X minus 2 minus 3 should be this, right? So it's negative, negative should be positive. So positive should be positive. This, right? And then what? The x plus 5. Let me erase this so that you can. So x plus 5. Let me just write here just to check. Okay. So 1 over 3. This is x plus 5 negative 2 over 3, or maybe I'll just write plus 1 over 3. Or maybe I will write 1 is here, so square 3. Oh, it's too bold. Can I make it thinner? 3, okay, that's better. X plus 5 squared. Okay. Oh, I think we can just erase the bottom part. Okay. No need here. And I think we can just take this into our equations. Okay. Okay, let's compute that this one will be 0. This part will be 0. Okay. And the other one will be what? The other one will be 0, 5, 25. It's 1 over 3 25 cube, right? Right. Okay. Or if you, I think it's still okay if you write this, or if you want to write maybe something nice like this is also okay, right? It's also the same. Okay, that is from the right. Okay, let's check from the left. Okay, I need to move this down a bit here, and maybe making this a little bit smaller. Maybe I will write on the right here, so I can erase this calculation. Okay, so limit Sx going from the left of f of x minus f of 0 divided by x minus 0. Now, because we have find the a, okay, let me write the equation is f of x is when x is less 0. Let me write first, so then you doesn't really confuse about this. So f of x is squared cube root 5 plus bx. Okay. Now the idea here is we need to find b through this formula here. Okay. Okay. Now we can compute that the f of x will be. Let me write the limit. Zero. It should be one, right? Should be one. Should be one. Oh no, that's the other one. Sorry, I mean for the f0. So minus the f0. F0 is this, right? Okay, so we can just write this over x. Okay, check the conditions, and of course you check here. We check the check is 0 over 0 situations. Okay, that's why we can take the L'Hopital. Okay, the bottom one is just 1, so we can kind of forget about it. And then we can check this become this. Okay. And we check the limit. Okay. Then we can have the result is this. And then compare with this. Okay. Now this should be equal, right? So we can find b. Okay. So okay, because of the derivative, or it should be differentiable. So limit of x. Let me write the whole thing here. So this will be 5 or 3 equal with 5 plus b. So b will be 5 minus 5 backwards. If you stop here, that's okay. That's okay. You still get point. If you want to solve and make it simplified, you can also do that. This will be minus 5. And maybe this will be 5, 15, 15, 15 over 3 minus 1, 14 minus negative. So the answer is A and M is this. Okay, so this is the answer, A and M, and then the B is this. Okay. Any questions? Any questions? Okay. So basically, what I throw here is what I explain here is first the basic in limit. Okay. The important thing, continuity, derivative, the limit definition of derivative. Uh, we can have this kind of formula here, or using the x plus h. Sometimes we need to use that in some problem to prove. But I think here, what we are doing is we need to make sure that the continuity happens and also differentiable everywhere. Okay, that's the key. So the left and right limit is having a important point here. Okay. Okay, and if you write maybe not really correct when you maybe try the L'Hopital and maybe you find mistake here, but because you already write the limit left, right for each uh, left hand limit, right hand limit, and also for the derivative definition, you still have at least 40-50% okay for the point. Okay, if this not really correct here, but if this correct and you get precisely good result, you can get a full point. Okay, so if you have maybe or if okay, if you find the constant is not perfectly the same as the correct result, but the way you explain is good, it's okay. You can still get 70-80% okay for the one question. Okay, so everything in details here, like explanation about the left hand limit, right hand limit, this limit definition here for derivative, that's the big point. That's the big point, okay, for this kind of question. Okay. Okay. Any questions? Maybe from the online students? Do you have any questions? Okay. Okay. This is the similar idea, and if you want to write and you take notes, okay, you can check. But I think I will not explain this today. I will go to another one. But I think you can try if you want to solve it, maybe at your home. You can check. Okay. First is you have a function that is defined with these two equations, sine squared ax. Let me just zoom in for this equation first. Okay. Sine squared ax over x. Okay. This is when x is positive. So it's from right hand limit if you use the limit. Okay. And then you have as absolute value. Okay. 2x plus 1, 2x minus 1, plus b cos x, and x is less equal 0. The question is similar. You need to find a constant. Okay. You need to find a constant a and b. You need to find a constant a and b, and a and b is a and b is constant. And you have two conditions here. For what values of a and b if the functions continues at x equals 0. So of course we need to left hand limit, right hand limit. Okay? And the key here is this absolute value. Remember absolute value. If you have the from negative, then should be changed to negative. Okay, should be with positive. It's the positive one. Okay, so use left hand, right hand limit. Find the a and b. Okay, and of course, the sign. Okay, remember sign. If you have limit as x approaching 0, sine x over x equal 1. Okay, remember that the definition. Okay, using that formula or that principle, I think you can solve for continuity. And for B is also similar what we have done. Okay, differentiable, you use the limit definition. Okay, check from left, check from right, and you can also get the A and B. Okay, so you need to check this is f of x, and then also check the f0 because it's differentiable at x equals 0. Check when x0, check when x0. Okay, and uh, you can get A and B. Right? Okay, there's nothing missing from what we have done from the first one, the number one. Okay, I hope you can solve this okay, on your own. Okay, so you can take notes first for the question. And let me check the what can we have. Okay, okay, there's no question. Let me move to another problem that I think it's also important. I think. Oh wait, this. Yeah, I think we can check this first. Okay, just to check your skills on derivative. Okay. Do you get the results? Oh, okay. You can derive using sine over cos using quotient rule if you forget. Okay, the derivative of tangent is secant squared, right? Okay. Yeah, you can just plug in this. You already got the derivative form, right? If it had 0, maybe it will be simple. Right. How about the online students? Do you get the results? Okay. Okay, let me write this. Tangent x minus y. Let me write, if you have tangent x and you need to derive, this will be secant squared x, right? Here we have x minus y. Okay? That is if we are having an implicit that where y is function of x, then this tangent is still secant squared and x minus y, but you need to multiply with the chain rule, right? The chain rule will be the derivative of x minus y, right? Which is the 1 minus, let's say dy dx. Okay. Okay. Now it's equal with the, let's say we have the 1 plus x squared, the quotient rule. So this will be dy over dx, multiply with this, minus y, and then this is 2x, right? Okay. Now the idea is we are not to find the dy dx on this simplified form. We just see that we need to find dy dx when x is pi and y is 0. Okay. If you think that maybe if we just plug in all thing here, so secant squared pi, and this is CL1 minus dy dx is equal dy dx. This is 1 plus pi squared, and this is 0, and this will be 1 plus pi squared. So we can remove this. And secant squared pi is 1, yes, because negative 1, okay, squared. So this is equal 1. So 1 minus dy dx is dy dx over, okay, we can move to, so dy dx. Um, let's solve this. 1 plus, oh, I think 2, I can write 2 plus pi over square. So dy dx is the answer. Anyway, okay. What I did is I just differentiate this tangent and this right side, the quotient, the fraction, using quotient rule here. Okay, this is the tangent, okay? And then using implicit and having dy dx. Okay, this is also having the implicit dy dx having this. Okay, okay. If you want to simplify this first, that's okay. But my suggestion, if you are actually, you need to observe this pi and 0, right? X at pi and y is 0. If I were a student, if I was a student, I would just put into the equations, okay? Because I believe that this 0 will help me to reduce some of the formula here. Okay? So 0 here's going remove y, right? And then pi here, secant squared pi, it's squared, so it's just 1. So 1 minus dy dx, and then we have 1 plus x squared, it's 1 plus pi squared, and it's precisely the same form. We can remove, and we can just simplify, okay? If you compare with, if you try to solve this first, you try to find dy dx is equal something simplified first, you'll be at least several minutes. Your time will be not really, right? Not really efficient. Okay, not really efficient. Okay. So first look at the question here. Okay, if the question asking dy dx and it's already have some point. Okay, my suggestion is just plug in the point whenever you have the derivative. Do not try to find or solve the dy dx in some equations. Okay, it will take some time. Okay, just plug in the point. Okay, and then solve it and simplify it at the end. Okay. Of course, the idea for arranging the points here, okay, if you're able to derive, it's some percentage you will get, okay, maybe 30-40% here, okay. Here, calculations using the pi 0, if you get correct, of course you get also another 30%. Or maybe this is I think huge here. This will be huge. I think maybe half of the point will be here. But if you make a mistake here, so maybe you don't get some points. and maybe at the very end you take a mistake. Maybe you have missing 10% or 20%. Okay, so the first derivative here is I think important. Okay, if you did correct here, then at least half or 60% of the point you already have. Okay, okay, that's the derivative implicit. Okay, so let me write here. So this is implicit differentiation. Oh, wait. Implicit differentiation. Okay. Okay. Oh, okay. Try the second one. Okay. So evaluate the limit. Okay. I think it's still warm, right? You still just solve it. I think last week we still discussed this. Okay, anyone got the result here? Okay, I think first thing is we check, okay, that this is the indeterminate powers, right? Of 1 with power of infinity. Then you can let some y as your function here and take the ln both sides, and you have the ln y. Or maybe 1 minus cos x. This will be ln x, and this will be ln. Yeah, I think that will be okay. Yeah. And then both we approach with the same limit. We check this one here. It's the same situations, right? That is, we can use the Lopita rule. So it will be 1 over 1 minus cos x. This will be 1 over x. And this will be sine x. Okay. Here. Okay. Now let's rewrite the equation first. Okay, let me check the equations. Okay, so this will be x sine x, and then 1 minus cos x. Okay. Okay. I think you can do Lopita rule one more. But I think, okay, I just also want to remind you all so that we can also do this. It's okay, right? This the left one here, this is equal 1, right? And we can focus on this part, that is limit. Okay, we can, I think, do the L'Hopital, I think, with the simple functions. Okay, not too complex. So L'Hopital, and then this will be sine x. I think you still do L'Hopital, all L'Hopital there. Is there a way to change? Oh, I think I know. Okay, I think we can. Let me think. Okay, if you have the cos to alpha. Okay, sometimes this is helpful. Okay, for okay, if you think like from 1 minus cos. Okay, if you think that you can make it into squared, you can think this form. Maybe you can use this. So 1 minus cos to alpha is 2 sine. Okay, so 1 minus cos x is 2 sine squared x over 2. Okay, I think we can use this. I think we can still use this. Okay. Okay, but is it helpful? Yeah, this is just you can think this way, or if you want to do L'Hopital again, I think that's also okay. You can do L'Hopital again. And still do L'Hopital until you get that the result is 2. Yeah. Okay. Okay, this is just, I want to show you that sometimes, okay, when you have this 1 minus cos, you can also, like, you can rewrite into this squared form, okay. Okay, sometimes you can think this way, okay, if you want. Okay, so far we have 3 questions. Okay, let me take another one. So my plan is maybe 5 questions. I have 5 questions. If we still have something that is missing, I will provide a video for you, okay? Okay, this is still a function, I think. Okay, I think this first, this one first. Okay, this one first. Oh yeah. I forgot the answer. Yeah, e squared. So yeah. Thank you, Evando. So the answer will be, so limit. Don't forget to take the answer like that. Okay. Because we have the ln form, that is, we need to raise the power from the e. Okay. Yeah, I almost forgot. Thank you. Okay, that's the L'Hopital. This I've skipped this first. Let me just start with this one. Okay. We have the ellipse region. Okay. I think you can. So the figure shows a lamp. This is a lamp. Okay, lamp. Located to the right of the y-axis, so y. So this is the lamp here, 4. Okay, and a shadow created by some ellipse here. Okay. Some ellipse. Okay. So it's having a light from the lamp and then having a create a shadow. If the point -60 is on the edge of the shadow, okay, so it already have a figure, so it should help you, okay. If this is no figure here, maybe you need time to draw first, right? But it's already here, the figure. So -6 is the edge of the shadow. How far above the x-axis is the lamp located? So it's asking, it's already has question mark here. So it's asking how far the lamp should be. Okay, so you need to figure out, or you need to find the height of this lamp. Okay, If you got the result, you can write in the chat box for uh, online students. First, you have the ellipse, right? You have the ellipse. You have the equation of ellipse. I think, okay, from the figure, you can find out that it has these 2 points here that is touching the ellipse, okay? Which means this is the tangent. So this is a tangent line problem. So first we can find the tangent line. Okay? How to find the tangent line? First, you need to find the slope. How to find the slope? You have the equation here. Find dy dx. That's the slope. Okay? First, find the slope. And I think the slope is, you need to evaluate the slope at this x, right? To get the height, right? Okay. Actually, there are several ways to solve this, but I think the easiest one, or the one that not really having much calculation, is using just the implicit differentiation. Because if you use the tangent line, at least you get negative 60 for 1 point, right? So you can find the tangent line of this one. You can find the slope from here, right? At least you have 2 equations, right? 2 equations from there. Do you get what I mean? Okay. So first, you can find this. Let's say this is the point, right? 60. Okay. And this is, you have a tangent here and tangent here, right? Or let me just write the equations here for you. So that the equation will be x squared plus 5 squared. Let's say we have 6 like that. Okay. This is um, the ellipse. Okay. So let me write this, the ellipse. Okay. So first, from the ellipse, we take the derivative implicitly. So 2x plus 10 y dy dx equals 0. So dy dx is equal negative 2x and y, or negative x over 5y. Okay, this is our slope relations, okay, with x and y. Okay, now the line equations, we have this, right? The slope we have from the dy over dx, the slope, okay? And we can take the point that is at negative 60. So this will be y is 0, so y negative x, y, x. Let me to make it less confusion. I think I need to take different. So x minus or plus 6 y. Sorry. And then we solve this. X0, X0. Okay, so X0 is here. X0, Y0. Okay, so Y, now to make it less confusions, okay, let me write maybe to make it more clear. So Y, X minus the 0 plus Y0. At X, I think this is better. I think this is better. 0. Six, negative 6. Negative 6, negative. I think this is better. And then compute. And then from here, at X0 and Y0, we know that this is equal to this. Okay. So in the conclusions, negative 6 X0 is equal to 6. So X, our formula for X is negative 1. And then 1 plus 5 equals 6. And then 5 y squared is equal to 5. So y squared is plus minus 1. But if you look at this one here, should be positive. So this should be equal negative 1, 1. So x0, y0 is negative 1, 1. Okay. So the tangent line is y negative 1 over 5. X plus 6 over 5. So y at x equal 4, that is where the lamp is at. It should be 10 over 5. Should be, oh, sorry, this is not negative. Because it's negative, negative should be positive, sorry. So 4, 5 should be 2. So the height, so the lamp height should be 2 units from x-axis. Okay. Okay, so basically the idea is just to find the tangent line here. Okay, can you find the tangent line? Find the point for the tangent. Okay, find this. Yeah, perhaps I make some confusions. I think I need to just use AB, I think, right? Because using X will be having some confusion here. If I'm using AB, this is the point that we need to find first. Okay, so first find the derivative. Okay, the derivative is the slope, okay, the gradient, and the gradient. Okay, this x0, y0 is just my point here that we are going to find. We have the tangent line, okay, and we are going to take the tangent line. So I think we can just using the 0 to make it the same. Okay. So at this negative 6, 0, we can just plug in the x and y. 0 for y, and x is negative 6. And then we can check this, compute the equations. Okay, after you find these equations from the tangent, okay, so after you find this equation here, okay, perhaps you feel what can we do after this one? Okay. If we look at this, this is perfectly fit with our ellipse. Okay, it's perfectly with our ellipse. So that's why we can exchange that with our ellipse. That is this 6. Okay, so that's why this becomes this. Okay, because this is the ellipse equation from our question. This is perfectly 6, and we get the x0, or our point. The x is negative 1. Okay, why we need to find the point? Okay, why we need to find the point? We need to find the point so that we can find the slope. Okay, we can find this the slope value, and then we find the from the x we find the y. Okay, we find the y, and we choose the positive value for y, and we got the point is this. Okay, the point, and then put in the point, and then calculate become our equations. Okay, now this tangent line equations, okay, is basically this line here. Okay, so this line here is y. Okay, so at x equal 4, this is our height. Okay, so when we have x equal 4, then we can just compute 4 into our line equations. That is the height of the lamp. Okay. Okay, I hope you get the idea. Okay. Okay. Let me find another problem for you. Which one is suitable? I think we can move to previous one here. I think this is not too difficult, right? I think I can just skip that. And this is two questions, okay? Two questions. So A, B. I think this is also limit. You can check if you want, but I think I'm not really solving this one first. Let me find another one for you. Okay, I think I can give you this. Okay, let me skip this first. Okay, this is, I think you can do it on your own. Let me write for you that L be any line through point 324. Okay. The equation of line L, which cuts off shortest segment by the first quadrant is, find the equation, and the length of the shortest segment is, find the value. I think this is a good approach for it. Okay, so first, if you look at the picture, you can check if you want to roughly sketch the graph. Okay, maybe 324, maybe here. Let's take a line. So cuts off the first quadrant is like that. And then what else? Shortest segment, okay, length of the shortest segment. Okay. So this is 324, this is L. Okay, let the Y, this is our line equations. First, that is our conditions, and the slope need to be negative, right? It's going down. And what else? We need to find the x-intercept and y-intercept. So finding this, x and y here. So x-intercept will be 3, right? Or maybe let me write it more clear. So when x is 0, and when y is 0, okay. Now we have these two equations for x and y. Okay. The L then, so we need to find what is L, right? How short it is. Okay. To find the shortest possible. So L squared is x squared plus y squared, right? That's the one that we are going to find. Or let's say this is S. Okay, so let's just S, because we don't want to have the optimization on the square root. Okay. Okay, so S is 3 minus 24 m plus 24 minus 3m squared. Okay. Yeah, a little bit calculations. Let me just write 24, 24. I'm lazy to calculate. 24, 24. If you want to calculate, that's okay. I don't want to. 24, 24, negative plus 9m squared. Okay. Okay, solve this. This should take the form of 9. This is 65 minus, because this is, you have okay, so it should be functions of the 16m plus 16 over m minus m squared minus 64 m squared. Yeah, it's a little bit longer here. And then take this as a function of g. Let's say this g. Okay. Okay. We need to find the way to minimize this. Okay. So we take the g prime. So so g. Let me write here. So g is 16m plus 16 over m minus m squared minus 64 over m squared. Okay. And the idea here, find this first derivative. And then solve this. Okay. I don't really have much time. I need to go fast. And then this is b equals 0. You need to solve this, and eventually you will get to find the m is actually -2. And then you need to use that into our equation here. That is L is 24 y minus 24. Or we can just to find the shortest length to use this equation here. So this will be 3 plus 12 to 15, or 12. This is 30. So the L, okay, it's a little bit confusing here, but yeah. Yeah. Okay, but the idea here is you need to find where, okay, so the inside this optimization here, when you try to compute this squared here, it's a lot of number here. When you compute and you see some part of functions here, okay, instead of using all equations together, you can use this as your optimization because it's still relate to our conditions, okay, for this S. Okay, so we find the M through our uh, another optimization here that we need to take. Let's say another function here. We take it to make the first derivative here equal 0. And the first derivative equals 0 means that if we solve here, solve the m, okay, and you can factorize later on, and you have plus minus 2, I think, plus minus 2. And because it should be, the slope should be negative, you choose the -1. And from there, you check the segment once more. You check the segment, okay? You check the segment once more, and then you get the value of the L, okay? The value of the L. So first, you can exchange this m with -2, which means you get y -2x, and then plus 6 plus 24 plus 30. Okay, it seems it's I think the difficulty here is the solving this quadratic, and because I'm having a lot of number, but I believe if the time is enough, we can solve this. Okay, we can solve this. Okay. Uh, let me check first. I think I can give you one for just maybe if you want to check it at your homework, as your homework, or just do your on your own. Let me check. Okay, let me put into this quotient here. Okay, you can take notes first. Okay, it's a little bit complex question, but I think if you can do um, slowly and within the process, you can tackle like a lot of chapters in one question. Okay. Okay. So suppose the function f differentiable one-to-one, which means why this one-to-one, you see the question is having the inverse. Okay. So this is also a review of inverse. I will try to solve it also and making a video for you for this one. Okay. And then adding some other questions as well. Okay. And yeah, I think you can try this. And it's giving you the idea of the f prime. You have this equation. And also it say that the limit of f of x over x as x approaching 0, it exists. Okay, it exists. And the first question is find the f0. Find the f0. And then find the limit as x approaching 0 of f of x over x. Okay. And then after you find that, show the f is increasing. Okay. So increasing means it should be the slope should be positive, right? And you need to check the concavity. The concavity means the second derivative. Check in this interval what's happening, how the concavity will change, and prove the f of x is greater or equal x for the interval 0, 1. Okay. And prove also the f of x is greater than x plus x cubed over 3 for 0, 1. It seems complicated. Okay, it seems complicated, but yeah, it's complicated one. And then the other one question is find the f inverse. For f inverse of a derivative of f inverse, and then find the f inverse and f of x. Okay. Do we have time? What do we have? Okay. Let me give you maybe a few steps to get through. Okay. First, let the limit of this. Okay, because it exists. Assume it will resulting some L. Okay, to make the questions easier to think. Okay? So the F0 means limit of f of x. Okay, so since, let me write first. Okay, let me write here that is since the function differentiable, because we have this f prime here. Okay, differentiable, it is continuous. So this this is limit f of x and limit. If we have limit this limit, it's the same as that. That is L multiplied with 0, right? So it will be 0. So F0 is 0. So first one. Okay. Okay, so this is important here. Okay. To let it with some constant. And then this is differentiable. So we also write we can say that this is the f prime 0, which is, if we look here, this is f prime 0, 1 plus f0 squared, right? So we can take this in terms of 1 plus f of 0 squared, that is exactly 1. So it says, it's interesting, right? So if you think from the question, it exists as an any finite constant, then from this limit we can write this, right? Is to find this limit of as x approaching 0, and we know that this will result in a 0, okay, for this f0, okay. And then if we check from here, we check the f of x divided by x. We check with the differentiable derivative definition of limit. That is they need to be to have some value. That is, this is f prime 0, and we know the f prime equation. We plug in 0 and we get the result 1 plus f0 squared. F0 is 0, so this is 1. So f of x over x, its limit is 1. Okay. Okay. The other is checking increasing. So since f prime x is 1 plus so since it's greater than 1, it is increasing. Okay? I think you get the idea from the 1 plus something. It's always increasing, right? So you can explain that it's always positive. It's always increasing from this equation. Okay? The rest you try. Okay? You try. I will make the rest in another video. Okay, and also with another maybe 4 questions, maybe 4 quick questions. Okay. If you have any difficulty, you can discuss with me. Okay, and also I can try to find a way to explain it to you. Okay. Okay. So that will be the end of our lecture. Okay, no feedback for you today. No feedback time.